If f of x equals e to the 3x times 3x minus 4, find any x values where a horizontal tangent line exists. So wherever a horizontal tangent line exists, that happens when your derivative, because, tangent lines, the slope of a tangent line is the derivative. So I want the derivative. And if it's horizontal, that means the slope is 0. So I care about when the derivative is equal to 0. So I've got to take the derivative of u. And this requires product rule. So I'm going to call u e to the 3x. I'm going to call v 3x minus 4. Now you might be thinking, this is 3.1. Why are we doing product rule? Well, here's why. Because now I have to find u prime of e to the 3x. Boys and girls, that's chain rule. You have a 3x living inside an e to the stuff. So this is chain rule, a function within a function. The way you handle chain rule is you take the outside stuff, which is e, and take the derivative of it. So what's the derivative of e to the stuff? E to the stuff. Keep the inside stuff the way it is, but then multiply everything to the derivative of the inside stuff. The inside stuff is 3x, so the derivative of 3x is just 3. So the derivative of e to the 3x is 3 e to the 3x. Nothing crazy. The derivative of v is going to be the derivative of 3x, which is just 3, minus 4, which is nothing. So that ended up nicely. That's power rule stuff. So f prime of x is going to equal u prime v. So this is power rule. So product rule, I'm sorry. If you forgot what product rule is, let me just write it out. U times v is going to be u prime v plus v prime u, the derivative of the first guy times the second guy plus the derivative of the second guy times the first guy. So the derivative of the first, the derivative of the first guy is 3 e to the 3x times the second guy, which is 3x minus 4. Ugh, this is not going to be pleasant at all. Plus the derivative of the second guy, which is 3 times the derivative of the first guy. So actually, I take it back. This is not so bad. Or as Eminem would say, not so bad at all. Okay, this is what I have here. All right, I need to now set this equal to 0. I have two factors here, u and u. And in both of these, I have 3 e to the 3x in common in both. So I'm going to pull out 3 e to the 3x out of both of them. When I do that, okay, I am left with 3x minus 4. And since for this guy, I completely pulled a 3 e to the 3x out of the whole thing, plus 1. So that's going to equal 3 e to the 3x times 3x minus 4 plus 1. That parentheses is useless. Minus 4 plus 1 is minus 3. Now, using the zero product property, my job is to find any x values where the horizontal tangent line exists. Okay, so I'm going to do zero product property and set u equal to 0. So 3 e to the 3x equals 0. And then in a different color and with a little less space, 3, and I could have pulled out a 3 if I wanted to, but it doesn't really matter. It's too late now. Minus 3 equals 0. Okay, so that's going to be the easy guy. That'll take me a couple steps. This, not so much. If I divide everything by 3, though, I now have e to the 3x equals 0. Okay, what I'll do is let me scooch you over. Let me drop down that 3x by taking the ln of both sides. So ln of both sides allows me to cancel out the ln of e, leaving me with just, and let me write it up here, 3x. Now, here's the tricky part. The ln of 0 doesn't exist. It's undefined. So after all of that, we get nothing here. That was great. That was a waste of time. But that doesn't mean we're not done. See, we have this other guy over here that we need to add 3 to, divide by 3, and then you get x equals 1. So after all of that, x equals 1 is going to be the only part that is going to give us a nice flat slope if I were to have it graphed here. So yeah, kind of a tricky problem, kind of a sloppy problem, but yeah, that's how we could use chain rule to answer some real life type questions. Fun!